string over near back, I think. Or an ear or a ear. An ear. E. Uh, I don't know. Anyway. Okay. Delete A. Nope. Given. You will not be given access to the head of the list. Instead, you will be given access to the node directly. It's not a tail node. Ooh. Okay. So how you do this is add the address of node. You put the address of node next. That's what I'm thinking. Hmm. Hmm. I think that doesn't make sense. That's equivalent of doing nothing. I was even asked this question in an interview. Um, I don't know. I'm gonna like try everything, I guess. Huh. Node is pointing to this. So you want wherever node's pointing to. So let's say and node. Let's keep a variable. Let's say list star star list node star star x equals the address of node, and x is now equal to node dot next the address. Does that make sense? Does that work? First of all, whatever. So x is probably the address of 5, right? And then you're saying the value of x now is now the address of 1. So it's just changing x's value. It's not changing anything in the list. What I want is the address ampersand node to be changed to ampersand node next. But it's saying it's not possible to do that. What does this do? Hmm. Do I have to? Come on, it's a one-line solution. Node equals. Hmm. Hmm. Anybody know? Node equals. So this is just a pointer to 5. Now we want a node. Now we want a pointer to the pointer that's pointing to the node. No, that's that's got the value that's in node of the value in node, right? And now we want to set that value to the address of node.next. Does that make sense? Oh, this is the value. The value of x. Okay, I've just written the same code again. Value of x is the address. So I don't want to reset the address. I want to set the. So I want to reset. So node is pointing towards somewhere, right? So we have a pointer. So where is it pointing? That is and node, right? And there will be some data, right? Which should be this on that. And we want to replace this with node.next. That sort of makes sense. You want to replace the data at that address with the data that's at that other address. Does that make more sense? Does that make any sense? So node is pointing towards something, right? So what's the address of node? No, no, no. I don't want the value address. I want the address of the value to be set to the address of the value. Does that make more sense? Does that make any sense? I'm just doing anything. Okay, so the value at that node, I'm setting that to what is the value of node? Node is a pointer. So the value of the node is actually the address. So what and node meant was the address of node, not the value of node. That's why I did the and star, because I want to go to the get the address of the value. Whatever. So this is the address of the actual data, not node. So the address of the data is now this. Okay. Ooh, so close. Right, valid anagram. So we've, how many easies have we done by now? 50. Okay. I don't know, I was thinking at least 100. I mean, maybe move on. Given two strings s and t, write a function to determine if they are anagrams. Assume this. What if the characters contain Unicode? I mean, the first and foremost solution is say we keep a map and if s dot size not equal to t dot size, return false, right? We keep a map of character int m, and then for each character c in s, if m dot find c equals m dot end, then m dot insert c comma 1, else mc equals mc equals mc plus 1, right? So then for char c in t, if m dot find c equals m dot end, then return false, else if m dot find mc equals 0, return false, else m dot m, sorry, we found it already, so you can just do mc. That gives you the value mc minus equal to minus minus. This should be fine. And then if everything works as expected, then you return true. Now we're just gonna try rat and car. Work, right? Should be false. And then we can submit. See, hash table sorting. Huh, sorting is also an option, I guess. Oh, that's pathetic. Okay, maybe unordered map, because we don't want sorting inside the map. Well, and how can we make it better? We're already exiting like well before time. Okay, maybe we can check better solutions. See on an average, it's a map. Okay, so it's kind of looks worse, or maybe not. I don't know. This is like the whoa. Okay, that's neat, I guess. Let's see, 8ms, 4ms. Okay, that's just using a vector, character vector, and 0ms is using a character array as well. So yeah, that's fine. Everything's, I mean, it's all the same, honestly. This is less memory, to be honest. Hey, that two maps are 26 character array. Unless, I don't know, maps are implemented in a way that make them larger. Okay. Ooh, happy number. That's one question we did yesterday, day before. Binary tree, given a binary tree, return all the paths. All the paths. That is so boring. You just want me to do DFS. Okay. Uh, so let's make a list. And it's called DFS on root and pass list and pass the current path, which is a string path, which you don't want to modify ever. And then we return the list, and then let's define DFS. It is a void function which takes in a star. Wait, I just got some. Oh, thanks Detox Mango for following. Uh, yeah, can't stream. Hello. Oops. Uh, yeah. Then you pass the vector string list. Pass by reference because you want to do this list every time, and then you pass the current path. Okay. Okay, so we want to print like So if I guess root is null, which means you've oh nah. Actually you need to check if the child left child and right child are null, because if you go down you're gonna double check left and right and then add the path twice the list, so you have to stop add the leaf and not go lower. So root right equals null, then list dot push, is it a vector? Okay, push back path, current path, and then you can just return from here. Or else, what do you do or else? So you're at the current node, you have to add that to the path. Path plus equals toString root dot value. We might have to make some changes, as well as this thing. So you're pushing this, so path plus equals to toString dot value, and then you just do just call DFS if root left, if you've left, then DFS on root left list and where the current path is, and same way if you have right, do that with right. That looks pretty much it. I think this is a part of the string library. I saw this yesterday. Of course. You have to do that. You have to add that stupid check every time. That's why people don't have a high acceptance rate on this. Okay, margin of error. Margin of error. I guess that's it. Looks good, I guess. Depends on how you make it toString or how you do this. String builder kind of things. Whatever. Okay, that's fine. Okay, add digits. Ooh, I don't think we want to do this. Given a non-negative number, repeatedly add all its digits until the result has only one digit. And why is it that bad though? While num is greater than 10, greater than 9, int temp equals num while temp is greater than 0, num int sum 0, sum plus equals temp%10, temp by equal to 10. I guess you don't need to use temp, you can just use num. Use the last digit and then remove the last digit is what we're doing every time. And then num equals sum, and then return num. Could you do it without any loop recursion in one time? That's a good question. Let me just check if this is right though. Okay, it is. in O1 runtime. So you want the sum of all digits forever till it only has one digit. Okay. So we know if it's a factor of 9, it's gonna be 9. And apart from that, we don't know anything. That's pretty weird question. So all we know is it's gonna be between 1 and 9. But like it's 11, it's 12, 13. Is discrete math a computer science thing? Uh, yeah, I don't think I don't remember studying discrete maths while studying computers. I don't think it is. Yeah, I know it's not. But I think it is related to stats somewhat. Or, I mean, depends on what field in computer science. Like for coders, definitely not. But for like data scientists, I think that might still make sense. Huh. So what I'm wondering is, O1. So for O1, you need maths is all. I mean, it could be a very large number like 99999, so you can't really say. But what can you say about a number? Sum of its digits. Without loops? Sounds crazy, right? And is that why it's downloaded? They're like, it's not loops, it's some other hack or something. Hmm. Huh. Oh, okay. It's not like writing a loop, but yeah, but then you'd have to do it for the result, right? It's still a loop. Hmm. I think I give up. The value as to compute is called digital root mathematical. Say what? Is this observable? 9. Holy shit, that just makes so much sense suddenly. Okay, yeah, you know why it makes sense? I'll tell you. That's crazy how much sense that makes. I didn't read the explanation, but just I'm just deriving from the question. So, what is this? Scan QR code. Huh? Okay. Alright, so what they're saying is, okay, so just imagine, so every number can be represented like this, right? Is 9 times k plus c, every positive number, let's say, where k is like whatever, 1, 0 to n, and like c is some, I don't know, 0 to 8, right? So basically, that's what every number can be represented as, right? So when you add, so just imagine what happens when you add a number that's a factor of 9, right? So that number for that number, let's say c is going to be 0, and it's going to be 9 times something, right? And um, if you keep adding the digits like 18 or like 189, these are like factors of 9, right? So if you add the digits, they become factors of 9 itself. And then eventually, because it boils down to the smallest number, it comes down to 9. So say if there's another number, right? If there's a c added to this multiple of 9, not factor, sorry, multiple, when I said factor earlier. If you add a number, another number to this multiple, it's kind of like adding that number over here, because in the end it's the same thing, because you're just adding, when you add that number here, so let's say you add 4 here, right? So that's going to add like 4 to the value and sort of like to the digits. I don't know if that makes sense. Let's take a case, a better case. So yeah, let's say you have 54, right? So when you add 4 to this, it's gonna add 4 to the number, but it's also gonna add 4 to this sum as well. So it still hold true, like this formula, that it'll be 9 times something plus something plus 4. And if you keep, and let's say it's like a huge number, right? Let's make that, no. Yeah. So no matter how you add to the digits or the number, it's gonna be the same thing, because in the end, these digits will add up and boil down to 9 or 0 if they're if this number is a multiple of 9. And a number that's not a multiple of 9 is gonna be 9 plus 4 or 0 plus 4, whatever that extra number is. So in the end, I mean, because after 9 it resets. So whenever you add 9 plus something, it's sort of leaves the 9, and this is what's left of it. Like if you do 9 plus 4, it becomes 13, which is 4. 1 plus 4. So after 9, every number is actually just removing 9 from it, and then whatever's left. That makes so much sense, right? I mean, how do you figure this out in an interview? I don't think so. Hmm. It's pretty crazy though. I think that it's a cool thing to know still. I don't know if it's ever going to be useful. Yeah, adding digits for number might be like, like combining something in the real world, and uh, you could use this hint as, like when you're squashing, I don't know how it worked, like pixels maybe, because you have to add those pixels and then add the digits of those pixels. I don't know if it makes sense, but I don't know, something like addition. It's like addition trick. I don't know. It's a neat trick. I mean, let's say you have like these 500,000 one-digit numbers, right? As say maybe like in like contiguous array, or so you just represent that as one number and then do modulus 9. That is just as good as like if to convert every number into one number. Maybe some sort of um, hashing, or not like a really good hashing function that makes distinct output, but like like an initial hash. Like if you have an array of you know how hashes work, right? Like so you can like bucket in hashes. So basically, your function could be like, okay, so every number goes to one of 9 buckets, 1, 2, 3, 4, 5, 6, 7, 8, 9. And how do you determine that? So if x is an integer, you could just do x%9. Uh, I mean, so if x is like 1, 2, 3, 4, and your function actually wants to like add these digits and then keep adding them till they're a single digit, that's your hash function. Instead of doing that, you could just do person9. That would get the same result, pretty much, unless I think unless it's 0 or something. And then you can bucket them in the same segment, and then you can just do whatever you want to do with this data, I guess. I don't know. I hope that makes sense. Okay, ugly number. Still downvoted. Let's see. I mean, heck, I should go ahead and upvote this. I like this question slash the answer. Kind of makes you think and stuff. Numbers whose prime factors are only 2, 3, and 5. Write a program to check whether a given number is an ugly number. Whose prime factors are only 2, 3, and 5. 14 is not. Okay. Hmm. So I guess if num is less than 0, just return false. Says a 1. Return true. Let's check for 0, I guess. Of course, I don't know how to write return. Okay, that's fine. And what about 1? That's not how you test 1. Up is false should be true. If it's less than 0, then it's false. If num equals 1, then you return true. Okay, let's see. Alright, so our positive numbers whose factors will include this. Okay, so let's just say we run a loop while um, temp int temp 1 equals that doesn't make sense what I'm thinking of. I was like keep checking it, like keep dividing it by 2 till you reach a number that is not divisible by 2, then keep trying by 3 and keep trying by 5, and if you're left with anything but 1, then just give up, right? Okay, let's do something. Actually, that might work. While true, so while num person2 equals 0, num by equals 2, and then while num person3 equals 0, num by equals 3, then while it's divisible basically, right? Num person 5 equals 0, num by equals 5. Uh, well, you don't have to do this anywhere. And now if num equals 1, turn not equals 1, return false. I guess that doesn't make sense. Or else return true. Da 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 Scooby Doo Doo. Oh, I guess you don't have to write that. 14. It should return false. And for 8, it should return true. And for -4, it should return false. And submit. Wait, I think I had to do 1. Ooh, ooh, ah, ooh, oh yeah. But like, I think margin of error, but that's low. I mean, what do most people get? 0? But like, yeah, most people did get 0. Like, okay. Well, literally the same code. Okay, let's see. Return num equals 1. I mean, if that's what makes difference, I'll be blown away. Like, what made what? What's up? Never mind. Let's move on. We already learned to, move on. Even if we don't get desired outcome like that. Sunday stream. Yeah, that is actually pretty cool, huh? Good question. Yeah, good question though. How do you do this in an interview? Are you supposed to know this beforehand? Yeah, I think so. I mean, pretty much. I mean, unless you're like a genius, you can figure it out in an interview. Some people do figure some crazy stuff out. I have a friend who recently did figure something out in an interview, which he did know the background of, but kind of didn't know exactly. I don't know how to describe that, but yeah, I think you're just supposed to know these questions. Like in interview, I was asked like a crazy question the other day, last year actually. It was how do you solve a DP question, like the most basic DP question using maths. So I can actually find that question. What was that question? Stairs. Yeah, climbing stairs. So it's like a DP question, kind of. It's like just sort of like Fibonacci. The answer is Fibonacci, but Fibonacci actually has a mathematical solution as well. So they say. I didn't go through it. It's kind of just a formula, obviously. It's an approximation, I think. Maybe, I don't know. Yeah, so basically the question is how many ways can you climb to n steps if you can climb either one step or two steps at a time. So it's just Fibonacci. Third is first second, second is third, as does here. And then there's these mathematical solutions. One is the Binet's method, which I guess some people who are doing data science might know, because I guess matrix multiplication or something is like a big fad in data science. And and then there's this Fibonacci formula. It's like we can find the nth Fibonacci number using this formula. 1 by root 5, blah blah blah. What? I don't know how it's derived, but yeah, so that's just the formula. So you can just give this as the answer. You're like, hey, this is the answer. You're like, oh, wow. Okay, cool. So yeah, these kind of things you sort of have to know beforehand. I mean, obviously you can't make this up. I think it during an interview. This add digits kind of thing, maybe. I mean, since it's not like some crazy formula or anything, it's just like maths. So if you like sat there for an hour or two, if you had that much time, and then you just sat and you know created a relationship between all the numbers, just kept writing numbers and seeing, okay, how does this number become that, or like, and then you maybe eventually find out that every number is actually like modulo 9. Maybe, I mean, that could be just luck, pretty much, if you were able to notice that. I think actually, if you do end up doing a lot of questions, um, if you do a lot of questions of a particular type, you do sort of develop a mindset to look at things in a different way. Uh, Happens with other things all the time. Like for other topics like stacks and trees, you kind of identify, okay, I could think in this direction and maybe that leads to an answer. But for maths, it's I don't know, it's maths. It's not trees. It's not concepts. It's like it's maths. Not all maths is concepts, unless you know it, I guess. Anyway, so I hope yeah that answers your question. Given an array containing n distinct numbers in the range 0 to n, return the only number in the range that is missing from the array. Could you implement solution by using no space and on complexity runtime? So it says there's gonna be yeah, so it's a n size array with n plus 1 numbers from 0 to n. So this is again maths. I don't know it's why that is so downvoted, but hmm, could you O1 space, yeah. So uh yeah, so I think this is just maths. So like what's uh the sum of first n numbers, right? It's n plus 1 by 2. So you could just store that sum equals um n to by 2, um, then for each number in nums, um, sum minus equals number. So you remove every number from 1 to n, and the number that's left is the one that you didn't find. Right? It's like so obvious. I mean, I've also done this question long back before, so I kind of know. This is a bad one. I've had this in an interview before. It's a bad one. But we'll come to it when you come to it. But yeah. Uh, I mean, but it is also kind of obvious, right? So, as a hint, when you see something like has a size, an array size n has numbers 1 to n or 0 to n, it has to be something like, it has to use like indices or sum or something like that. Uh, Especially like if it says distinct, then it has to be like some kind of maths or probably most probably some kind of maths mostly. Maybe you can see that if you see more questions like this. I'm not doing questions by topics. It's more fun to do by topic because then you're just like hashing out a topic and then you're getting really good at that topic at a pace. But I heard somebody in the discuss section long back, of course, a year back, I saw this post that said don't do questions by topics because then you know what topic you have to apply. I mean, unless it's trees and um, uh, stacks, or I don't know, not stacks, maybe trees and linked list and all that. That's kind of obvious, but you're never actually sure if it's arrays or if it's DP or if it's just normal recursion or it's stacks and queues. There are some like crazy good stack questions as well. So if you know it's a stack, it's kind of becomes easier for you. You're a product manager currently leading a team to develop new product. Unfortunately, the latest version, since these versions developed based on the previous version, all the versions after a bad version are also bad. Huh? Suppose you have n versions. You want to find out the first bad one, which causes all the other ones to go bad. Given is bad version, which returns version is bad or not. Implement function that finds the first bad version. You should minimize number of calls to the API. Hmm. Hmm. I don't know. I've probably seen this. That's why maybe I know how to do this. I don't know if you can guess how to do this. I mean, obviously there's the straightforward version of start with the first element and just keep checking is bad, is bad, is bad, is bad. It's gonna give you a timeout. TLE. So, like I said, like if you do questions of a type more, you get to know what type of question it is, like what topic it's from. So it's arrays, obviously, right? And you have to find. So I mean, they just like renamed it, but they're just saying to find a number in an array of numbers for which some condition is true, right? So like another condition could be, say the number is the mean of the list, or the number is a factor of some xyz prime numbers. Now the thing that you need to notice in such questions to identify what actually topic to apply is the clues that are hidden in the question. So they're not telling you some things, but you have to notice that since like they've also given an example that this array of versions, it's an array of course, is sorted. So it's going to be 1, 2, 3, 4, 5, 6, 7, and 9, n. So now the question changes that find a number in a sorted array. Now, how do you find a random number in a sorted array, right? You do binary search. And your condition is like if um, array x, array mid is the number you're looking for, return mid. That's the index. So that's exactly what you want to do here. But instead of checking if it's equal to some number, you just check is bad version mid. And that's your answer. This is just literally just binary binary search question. So where do how do we start? So low equals 1. I think the arrow starts 1, and high equals n. So while low is less than high, int mid equals low plus high by 2. If you want to look cool during the interview, you can do this, which is right shifting the number by 1 bit, which is also equivalent of dividing by 2. So yeah, you can look cooler, trust me. Um, let's wait it out. Okay, yeah. So if is bad version mid, uh, return. Oh, you can't return mid, cause okay, I forgot I have the question. So you're looking for the first bad version. Um, so how are you gonna find the first bad version? So if this is bad, right? Um, either like so this could be the first bad version, or this could be somewhere in between, or it could be the end. So if you I'll just draw it quickly. So in a list, let's say let's mark good by 1 and then bad by 0, and then everything's bad right after this. So when you go to mid, so either mid could be this, it could be this, or it could be this, or this. Like it has to be somewhere towards the right, inclusive right of the first bad. So whenever you find mid, if it is bad, what's on the right of mid is definitely bad. So we're always gonna cut short on the right side. Similarly, if you find a good version, everything on the left side of the good version is gonna be good. So you can remove that as well. So if it is bad, then high equals mid, right? And if it's not bad, then low equals mid. And then return mid. Now this might not work for turn. Might not work. I mean, sometimes you have to do like +1 and -1 and all that shit. So I think for this we can actually do this. Um, because if it's not bad, then we don't want low to be checked anyway, right? Because it's a 1. Even if it's the last one, we want this guy to be checked next. So let's check for some other numbers, like a even list. It works. Probably works. Maybe not. I'm stupid. Maybe we can do this. I don't know. Or you can just check if n is 1, just return 1 or something. Yeah. If n equals 1, turn 1. Okay. 2, 2. While 1 is less than 2. And 2 is the first bat version. Mid is 1 plus 2 by 2, which is 1. If 1 is bat version, no, it is not. Then low is mid plus 1. Actually, if low equals high, uh, return low. I don't know. This makes just as much sense, I guess. Excusez-moi. I mean, sometimes they just be like, oh, let's just put it like a really corner case, ha ha ha, you know. Screw you, dude. Screw you. Okay, screw you. That's what's up. Wait, what? This cannot be represented type int. I'm not trying to represent you as type int. Go become double. Swear to God. You know what? How about that? How about that, my friend? How about that? What you gonna do about that? Are you gonna tell me you can't do it? That's fine. You gonna tell me you can't do this? Hmm? What you gonna do? What you gonna do when they come for you? You kidding me? You kidding me? You kidding me? Okay, again. Low is 1, high is 2. Mid is 1 plus 2 by 2, which is. I wonder what it is for double, though. Mm. Double is decimal points, so. And this is a positively upvoted question. Never mind. That just makes you, smart enough to check those kind of conditions every time. Because like now in trees now I usually always check if the root is null or if an array is empty. They usually like put those things in the question, but I think if in an interview you can actually go ahead and ask the interviewer um, any missing gaps. But don't ask him too much, because then it'd be like, are you stupid? Just assume some stuff. Uh, just go ahead. Like if you don't want to ask him too much, then just go ahead and say, okay, I'm assuming this, and he'll correct you if he wants to, according to his question. Yes, I do code with the music. That is correct, sir. Uh, I mean this kind of coding definitely. The kind that is not too crazy. Like you can still think without uh, disturbing your mind. Like if you need to really focus, if you don't understand what you're doing, like so I think the last time I was streaming was when I said I am streaming till I get hired, and then I ended up getting hired, not because of the stream anyway. And I work at Microsoft now. It's been about 8 months, and so the work that I do there is really confusing because it's like old code, and there's obviously no documentation, and there wasn't like a great Katie or anything. So it's pretty hard to understand by myself because like it's just everybody like other people's codes hard to understand. So that I recently tried reading without I guess like yeah, writing code is probably easy because you know what you want to do, but thinking, I mean reading other people's code or like trying to understand some existing code is probably hard with music. And yes, that was Bad Boys, and yeah, it's pretty cool, I guess. Okay, given an array, write a function to move all the zeros to the end of it while maintaining the relative order of the non-zero elements. Hmm. Wow, that's like a highly uploaded. You must do this in place and minimize the total number of operations. So I guess I've done questions like this, probably this exact question as well. So I'll just draw this up quickly. 0, 1, 0, 3. I don't know. Was this it? Yeah, 12. So the best way to move a number like without making a copy is going to be swapping, right? So how do you swap? So you have one iterator on a zero and the other on a non-zero, and then you switch them. So this is what it becomes, and then you move the non-zero iterator. Let's call this n and call z till you reach another non-zero number. So you go here, no, no, no. Oh, you found it. And then you swap again. So you go 1, 3, 0, 0, 12. And now your non-zero is here and your zero is here. So you could like do that way, or you could just move this once and then this till you find the next non-zero and then swap and so on. And then that way you'll get the final answer. So let's call our zero iterator at zero and non-zero iterator at zero as well. So while I don't know, zi less than let's just store this somewhere in as nums dot size. And most people like do this for sure types. And n zi is less than n, like storing the size because it's like I don't know, it becomes intuition for them. Because generally use it more than once, sometimes not. Might as well. Hmm. Okay. Um. So while nums zi is not equal to 0, zi plus plus, so you find the first 0, and while nums non-zero index is equal to 0, um, nzi plus plus. So for our case, this is if it's not 0, uh, it does nothing because it is 0, and this is 0 right now, nzi. So num0 is 0, yes, so nzi becomes 1, and then it stops. So now that you're in the right place, you swap. So I don't know if this will work, but let's hope. Nums zi and nums nzi. You swap the values on these two, and then you swap you swap and set zi to nzi. Um, Sorry, dirtied it up. Can't remember. So this was your non-zero. Then you swap this with this, and this is the z. Okay, your z was pointing here, and then your nz was pointing here. And what you want to do is have your nz z um brain fart. So you want either you can start them both at the first at the yeah, I think you should just start them both with the next zero, the next number. So you swap um whatever comes first. Makes more sense, right? No. NZI will always be less than ZI because you want NZI to be on the left side, right? Huh. Actually, no. Um, so you only want to swap if ZI is less than NZI, then you swap. Uh, and then ZI is pointing at a non-zero, and NZI is pointing at a zero. So you probably want to start at the zero for both them. So ZI equals NZI, right? What if ZI is more than NZI? Doesn't matter, right? If it's more, one more thing, I guess. Um, if it's less, then you start with a new number. Then you start at the, any question? Huh. If you, if Zi is less than NZI, then you set, oh, you set this after, of course. Um, but if it's not, say if it was like 1, 0, find the first non-zero. You don't want to swap, and also you want to set nzi to zi. Yeah, I guess that makes more sense. Else nzi equals zi. Yeah, I think that is what it should be. Close. 1, 2, 3, 0. What? While they're both less than n. So, or if it exceeds n. I mean, this does happen, I guess. So let's run through this question with the code actually. Um, I think I saw an eraser. Okay, so it is 0, 1, 0, 3, 12. 0, 1, 0, 3, 12. So you have Z and N. Let's keep it separately, that's not a point. So Z is at, okay, let's keep the indices here, 0, 1, 2, 3, 4. So Z and N are 0. So while this guy is not 0, plus plus, while this guy is not 0, you set this to 1. If this is true, which it is, you swap these numbers. So now the array becomes 1, 0. And then you set Zi to Nzi. So this becomes 1. Again, you start from start. Zi is and Zi less than N. And Nzi is less than N. I'm just gonna run this just to make sure that it doesn't break something more. Okay. Yeah. So Z's not gonna move, because it is 0 already. And if it is 0, Nzi moves. So Nzi becomes 2 and then becomes 3. So then Z is less than N, so you swap again. So this becomes 3 and this becomes 0. So now if Z is less than this, start with this guy. Huh, no you don't actually. In both cases, set just don't do anything. Find the next 0. This Let's find the next 0 and that guy finds the next non-zero. So I guess that's still fine, right? Yeah. So let's check what the next one does actually. Do nothing, okay. Now while Zi is not 0, find Zi, so Z becomes 2. While num Zi is 0, just putting this because then it doesn't make sense to check because it's outside nums then. Um, yeah, so while this is a 0, which is true, becomes 4. So now it's 2 and 4, so you'd swap 2 and 4. So this becomes 12, this becomes 0. So it's 1, 3, 12, 0, 0. Oh, thanks for the follow, Flatman. Flat Math. What's your Discord? Is Twitch chat real or is it a figment of imagination? Huh. Good questions. Are you real? I think these might be Twitch bots, actually. Looks a lot like it. Or I don't know. quite a good bot. So now it is less than n. So 0. So if nzi equals n, I think you can just exit. Because you've already checked for a non-zero number after a 0 and you didn't find it. So you're probably done. What the frick? Okay. So z becomes 1. Oh, okay. I don't think this doesn't have undo, which is so weird. Okay. So let's see. 1 and 0. Zn. 0, 0. Why you don't find a 0? Oh, I'm only swapping. Why so, bro? Why so selfish? Frick me. Corner cases. What? Ah, this also makes sense. Like if you didn't find a 0, if there's no more zeros, you can't do anything. This makes sense that you should only swap in case the 0 is on the left side of the 1. Okay, let's see what I stopped running debugging it, so I should not just assume stuff. Okay. So, where was I? Yeah. So let's run 1 and 0. 0. This is the index. So find the first non-zero, it's at 0. Find the first 0, it's at 1. You don't have to do anything then. Don't swap, that's cool. So while oh, if you don't do anything, what happens then? Oh shit. Oh shit. Huh. I guess then it makes sense that if you didn't swap, right? So they were already sorted. So you try and find the next non-zero number. So you probably have to move NZI. Hmm. I wonder if like they have a neater solution or if it's pretty much just as much code. Subspace optimal. What? Oh, no space, please. Space optimal, operation suboptimal. What? Okay, I don't know. Whoa, what is this? What is this? Okay. The rest current position can be at best its current position or position earlier. If it's not zero, I guess, I mean, I don't know. I think it's given that it says that it's like, I guess it's pretty much the same, right? Same runtime. Last non-zero found at the current number is, so this is actually swapping for every case. Maybe, I don't know. It's actually swapping for every non-zero. So let's say 0, 0. So let's say it was 1, this case, right? 1, 0. This swaps this with itself. Then moves on. It's non-zero, then swaps. It says 0, 1, 2. Um, if it is non-zero, then swap. If it is non-zero, then swap with the last 0. And then you move 0 ahead. So, hmm, hmm, hmm. I guess this is still more operations than this. This is gonna swap the same number with itself quite a few times. This is only gonna swap. I mean, in case, let's say it's all ones, right? This is gonna swap a lot, and this is ain't. If operations mean this and not just checking, then yeah. It is still ON. Okay, let's see where we at now. Oh, by the way, if you actually wanted my Discord, I don't know, I might update that in the channel info, I guess. Twitch. Um, just a sec. Okay, let's read the next question at least. Word pattern. How do I change my like page description or whatever? Huh, huh. Channel. Huh. Bio. Nope. Wait, I don't know. That might be it. Schedule. Nope. Okay. I guess. Is that it? Let's see. Yeah, I guess that should come under bio section. Yeah, that's pretty much it. Yeah, so I've added my Discord there. Yeah, I guess that should come under bio. Wait, add social links. Yeah, that's pretty much it. Yeah, so I've added my Discord there. Yeah, I guess that should come under bio. Wait, add social links. Oh, whatever. Okay, cool. Cool, 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 cool. Given a pattern and a string s, find if s follows the same pattern. Say what? Here follow means a full match such that there is a bijection between a letter in pattern and a non-empty word in string. So basically each character maps to the same word in string. Did I just tell you the solution? Looks like map, might be map. Alright, so what you have to do is, I don't know, does C++ have like string split? Something like string split? Oh, hmm. I'm just checking if there's a simpler way maybe. Hmm. That's a lot of work. I don't want to write this code. It's too much code to write. And if that's the answer, then it doesn't make sense. Two hash maps. Is that all? Single index hash map. A and dog map A. Index of A and index of dog are the same. B and cat are the same. Ah, dog, cat, fish. Yeah, that also makes sense. So it is using maps. I just want to see if it. Oh, why am I just writing C++? I know JavaScript, right? That if I ever have to use like some crazy side functions. Two hash maps. Why did it say two hash maps? Can we have like a key value for key is the character here and this is the value? What's up? Nope. Palms. Cool. And if sure. If the value is the same as what you find. Yeah, how are they splitting though? Yeah, they're just using split cheaters. Alright, no need to solve this. It's just too time taking, I guess. We are at about 60 questions now, should be. No? Kinda tired. You're playing the following game. Oh, I think this is a very weird. I think this is again a trick question. Super downvoted. Wow. Given n the number of stones in the heap, return true if you can win the game. If you can win the game, assuming both you and your friends play optimally, otherwise return false. On each turn, the person who removes the last stone is the winner. If you can, yeah. So if I'll tell you what the answer is. Return n is less than 4. That is the answer, my friend. Ooh, works for 4. Ooh, works for 3. Ooh, works for a random number I just wrote. Yeah, so basically what they say is that every problem can be converted to a problem with like n equals 4 or n equals, yeah, 4, 5, 6, something. And then you always win if you can do that. I mean, if your opponent can always bring you down to n equals 4. If n is 5, he takes 1, you lose. If n is 6, he takes 1. He takes 2, you lose. If it's 7, he takes 3. If it's 8, he takes 1. And then you're at like 4, 5, 6. And then you can take 1, 2, or 3. So if you take 1, he takes 1. And then you lose. And if you take 2, he takes 1. And then you lose. Wait, if you take 2, if you have 4, probably takes 2, not. If he has 7, he probably doesn't take 1, he takes like 3. So it becomes, if he's at 8, then he takes, I don't know. That's the point is like he can make you, put you in a situation where you have 4, 5, or 6, or something, and then you always lose. So yeah. N is 4. Huh. Just like missing like a small thing there. It's person 4, right? Yeah, and person 4 not equal 0. I was thinking like how do you lose 5? Yeah. I guess that random number wasn't really smart, huh? Hmm. Otherwise, you always win, that is. Because you can always pick 1 or 2 and make it into that situation where n is 4 for him. If it's already 4, then you lose, I guess. My bad. Okay. Range sum. It's a pretty downward question and I'm tired of doing downward questions. Power of 3. It is a power of 3. I just did power of 2, right? So I don't know how this is any different. If n is less than 0, return false. Then or else return n%3 equals 0. Hmm. While n by while n if it's completely divisible, it's a factor of 3, not a power of 3. If n by 3 um while n by 3 is greater than 3, I guess. N by equals 3, and then return n um n no that's not right. So like int x equals 3 while x is less than n, x times equals 3, turn x equals n. This might fail for a big number, so let's go long. So number 27. Is that like a pretty big number? I don't know, like it's not a valid integer, that's okay. Try this one. Let's try and submit. It's fine. Output false. Expected true. If x is less than 1, if x is equal to 1, return true. If n is equal to 1. Hmm. Yeah, I'm kind of tired. So we're about like about 60 questions, some that are not done, skipped, included. Um, I don't know how worth it is to do all the questions. Actually, I've not done all topics, so I think it does make sense to do more questions. Since I guess like they have sort of harder questions, more complex questions later on, in easy even. But I don't know. Like I've not done a lot of topics. I can tell. I've done like basic trees, basic arrays, basic math, basic string, basic hash table, basic recursion, bas super basic bit linked list. That's all. So that like I guess it's a good time to say we can just skip to medium now. Or we can do topic wise, since topic wise is a bit more fun, topic wise, difficulty wise. But then you know you're doing that topic. But I guess it's fine for practice, I think. For practice, like for learning, it's fine. For actually practicing, like challenging yourself, it's better to do it without context. So I think for challenges we might just do um, contests, weekly contests and all. Um, to get random questions. But I guess it's fine to do just topic wise. So I guess we'll start with topics later tonight or tomorrow. Um, hmm. To get back into the that section as well, the system design. So in case you guys need a source, I I haven't been updated in a year. I haven't checked out new resources, but since I see Algo Expert ads to late, I guess makes sense that use that older resource is still a better option. Shh, work stuff. Don't check that. Just open Google Git system design. Yep, this is it. I mean, you should like fork this or something, System design primer. It's like a great repo. 6 months. Okay, it might have been updated. Maybe not much. Yeah, so this is like a great starter, at least starter resource for understanding any and every generic system, uh, online applications software system. It's really good, honestly. It's really, really good. You should definitely check it out. It's a little scattered, I would say, actually, in what order to go through, but you should. And I went to the short course, which meant like I was just skimming over stuff and I didn't read through details. But I think now probably have time. I'm not looking to switch right now, but um honestly, I've realized that you'll be happier if you do something you like, and it might be it probably is coding, but it's not what I'm doing here at MS. I mean, you know what gets me excited? It's Discord, stuff like Discord, and I'm like so sure that like if I had a chance to join Discord, I definitely would. Um, so I'm actually preparing sort of for that. I don't know if it's gonna be possible or not anyway. Like even as a um hackathon project a few months back, I made like a small Discord itself that you can use if you like. It's called Talking Rooms .azureWebsite.net. So just take a name and add a room name, whatever room do you want your friends to join in. 222 join, and then anybody else that joins the same room, ABC joins the same room. Not
Not
you're both
you're
in the
both
same room,
room
and you
and you
guys
guys
talk.
talk.
So yeah, that's like the basic of Discord, I'd say. And it's not done the same way Discord does it. It's Discord is a lot more complex, uh, which was kind of difficult. So I couldn't do it at the time. It's This is sort of a different solution for smaller groups because it makes a mesh system and connects everybody individually, unlike Discord that does it Like it uses a server as one host and connects all users to that one host, and then combines the audio or whatever stream on the server and passes it as one stream, and then decodes it at the client. So yeah, and does it pretty seamlessly, like, and pretty fast. It's pretty good tech. That's also why I want to join Discord. Yeah, so hopefully you get motivated by this, by my stream. And well, thanks for coming to my TED Talk. And I think I'll see you later tonight. Bye bye.